Imagine you have a super smart assistant who can not only retrieve the information from anywhere, but also generate the precise, insightful response. This is the magic of Retrieval-Augmented Generation, nothing but RAG. And in today's video, we are taking it to next level by introducing the LangChain. We are exploring how LangChain makes it easy to integrate the indexing, retrieval, and augmented generation into the RAG system. So you can build a powerful AI application faster than ever. Welcome back to our machine learning and AI series. In our last video, we are talking about the indexing and retrieval strategies. Today, we are dive deep into how to build a RAG system using the LangChain, covering everything from the indexing to query augmentation and generating the response. If you are excited how to level up your RAG system with the LangChain, then hit that subscribe button to let's get started. LangChain is a ultimate toolkit for building the RAG system. It helps to connect your applications with the data source, enables to retrieval and generate the smooth and integrated way. Here is how LangChain supports this RAG system. First thing is seamless integration with the data source. LangChain make it easy to pull the data from the database, API, cloud service or the documentation repository at easier. Advanced retrieval techniques. It simplifies the choosing the right retrieval methods where you can need to dense, sparse and hybrid retrieval. Customization. You can tailor the system to fit your exact project needs and adjust everything from the algorithm to data source. Optimization and performance. LangChain boosts the performance of your RAG system with the caching and parallel processing, ensuring fast and efficient retrieval. How to do indexing with the LangChain? In previous video, we'll discuss the importance of indexing in a RAG system. Now, let's see how easy to use the LangChain in this process. We'll use the ChromaDB to store and index our document, so we can later retrieve them efficiently. First, ensure the following packages are installed. That is first thing LangChain, LangChain OpenAI, and LangChain Community and ChromaDB. Here is the quick look at the code to embed the document using the OpenAI embedding and store them in the ChromaDB. The first thing you see here is importing the necessary libraries. The OS is a built-in Python module that helps us to manage the environment variables. Next, the LangChain OpenAI gives the tools to work with the OpenAI embeddings. Next, the ChromaDB is the library to create the database for working with the AI embeddings. Next, the .env will give the tools to load the environment variable which is defined on the .env file. Load.env is a function used to load the environment variable from the .env file into your Python application. It is essentially allows you to manage the sensitive information like API keys or password separately from your code. In this line, we are assigning the OpenAPI key value to the environment variable OpenAI key. Next, in this line, something we are calling the OpenAI embedding model. First thing is, what is embedding? Imagine you have a sentence called JavaScript is a good programming languages. And embedding is a converting the sentences into the bunch of numbers that AI model can understand better and easily. Nothing but converting the AI text into the numerical value, those that AI can understand and can process easily. And here, a list of sentences or nothing but a document that is just a piece of text we want to process with the AI. Think of it as an input data for your model. Now in this line, we are creating the ChromaDB using the Chroma. This database stores the embedding for each document, so later we can search or compare with them. To summarize this code, first thing is setting the AI model to generate the embedding for your text. Next, we are creating the database with those embeddings for the further use, and that's it. It is a simple piece of code. Let us know in the comments below if you have any questions on this code or you want to learn more about this. In this code, we create the vector embedding for each document and store them in the ChromaDB. This indexing vector store will allow faster retrieval later. How to retrieve with LangChain? Once we index the documents, the next step is to retrieve them based on the queries. In the LangChain, we make this process simple by using the method called asRetriever. Here is how it works. So what happening here? Here, we are telling the database to act as a retriever. A retrieval helps us to find the information from our database based on the search query. Now let's break it down this. Here we are saying that search type is equal to similarity, means we are looking for the documents that more similar to the query we provided. And the search query is equal to k is equal to 1, means we want to retrieve the one result that's most similar match. Next, here we are using the invoke method to pass the question. We pass the question where can I see the Mona Lisa. This query is compared to all the documents in our database using the embeddings. And finally, print results will display the closest match from the database. It could be sentences like you can see the Mona Lisa at the Louvre Museum. It does this by finding the most similar document using those embeddings we are talking about earlier. It's just a few lines of code. You have created a powerful search tool using the AI. To summarize, you turn the database into retriever and you pass the query and find the most relevant information for you. In this example, the retriever fetched the most relevant documents. Mona Lisa is at a Louvre Museum. This makes it easy to retrieve the exact information you are looking for, whether it's for the knowledge base or a set of documents. How to create augment query in the LangChain. Before retrieved information is passed to the language model, we can augment the query by combining the retrieval context with the original question. This refinement process improves the accuracy of a generated process. Here is how we create an augmented query. Let's start with the prompt template. A prompt template is a structured format that helps to guide AI to provide a meaningful answer. In this code, we are defining a multi-line string called the template. It's a set of clear instructions. First, use the provider to context the answer and the questions. Next, if the answer isn't clear, it's okay to say I don't know. The placeholder context and the question are like a blank. We will fill it later with the specific details. We are turning the raw template into something we can use. From template method from the prompt template, create the custom prompt template from the text we are just defined. We'll use this template to format our questions and the context later. Here we use retriever from our previous example to fetch some relevant context from the query. That is what is the future of AI. In the invoke method finds the most relevant information in the database and stores it in the context variable. Now the crucial part. We use the format method for our custom prompt to insert the context and question. We use the format method for our custom prompt to insert the context and question. This creates the complete prompt that's ready for the AI to process. To summarize, we define the clear structure of the prompt template and then retrieve the context using the retriever. Combining the context and the question into format the prompt for the AI. This process is super handy in building a smarter, more precise AI application. The result is well-structured query that includes the retrieved the context ready to be passed to the language model for generating a conscious and accurate response. How to generate the response in the LangChain? Now that we have our augmented query, it's time to generate the response using the language model. Here is how we integrate the model and create the RAG chain. First, we import the required tools. That is chat OpenAI is used to OpenAI's GPT-4 model. Then we runnable pass-through to pass the data through the chain without modifying it. Next, string output parse to format our output as a plain text. Here, we initialize the language model with GPT OpenAI model is equal to GPT-4. This tells us the program to use the GPT-4 to process the input. Now we building the RAG chain step by step. Let's break it down. First, we are starting with the dictionary, context, retriever, question, runnable parse-through. The retriever provides the relevant context from your database and runnable parse-through ensure the question moves through the unchangeable. Next, we pass the context and question to the custom range prompt, our prompt template from the earlier. After that, the formatted prompt goes to the LLM, which processes it using the GPT-4. And finally, the string output ensures that the output is the plain text that easy to use our display. Think of this as a pipeline where each part handles the specific task from the retriever context to the generating an answer. We use the invoke method to pass the question. that is what is the future of AI. The chain processes this question step by step, that is first retrieves the most relevant context, then they combines it with the question using the prompt template, then they sends the format prompt to the GPT-4 for the answer. The outputs the results in as a plain text. And that's how you build and use the LangChain. To summarize, start by setting up the retriever, prompt and language model. Then build the pipeline to process the context, question and response. And then use the invoke method to get the meaningful answer from your AI system. This technique is incredibly useful for creating a smart, context-aware application. In this chain, the retrieval fetches the relevant context, the prompt template augments the query, then the language model generates the responses. The output parses the format the responses. This pipeline makes it easy to handle each step in the RAG process, ensuring smooth and efficient generation. What is RAG evaluation? Once you build the RAG system, it is crucial to evaluate its performance. You want to test whether the system is accurate, how often does the system does it right answer. Then is the relevant information useful on the point? Does the generated response make a sense in the context? There is the various tools like WikiEval and Ragas that can help to measure these factors. By setting up the benchmarks and running the evaluation, you can fine-tune your system for the better performance. And there you have it. In today's video, we have explored how LangChain supercharges your RAG system by simplifying the indexing, retrieval, query augmentation, and response generation. If you found this helpful, give the thumbs up and subscribe to the channel for more in-depth tutorials. In the next video, we will take the step further by building the question answer system using the LangChain and integrate it with the user-friendly UI by the Streamlit. Stay tuned. I will see you in the next video. Bye bye.